Hi everyone, today in Integrated Math 1 we're going to be going over Chapter 9, Lesson 2. So one of the main things is that we need to recall are the definitions of mean, mode, median, and range. Remember, the mean is finding the average, which we did in our last lesson. We added together all of our numbers and then we divided it by the amount of numbers we had, and that gives us our mean. Our mode is going to be the number that occurs the most. The median is a center term when the terms are written in increasing order. Think about the median as the middle number. The range is going to be the max minus the minimum. Alright, so let's go ahead and go over a couple of the definitions. If we're looking at the different kinds of skewed distributions, our first one is the negative ones. And we want to know that the majority of the data is going to be on the right hand side. As you can see on the left hand side, it's really small, and then towards the right, it increases. Then if it's symmetric, it's going to be evenly distributed. So as you can see here, there's not necessarily a tail end of it because it's evenly distributed. However, if we look at the positively skewed distribution, we can see that a lot of it's going to start on the left hand side, and then we're going to get a tail towards the right hand side. As we can see here, the mean is going to be about the middle term in here, and that's where that's going to be. The median is going to be about the average. In this case, it's right about here, closer to the right hand side. For a symmetric distribution, the only thing we're going to be able to find based off the graph is just the mean, which is at the number that occurs the most. So that's why it's the tallest number here. And the same idea for as the negatively skewed, the median is going to be right here, and the mean is going to be a little smaller in this case. It's the flip version of this one. Alright, so for this problem, they want us to use a graphing calculator to construct a histogram of the data and use it to describe the shape and the distribution. So if we plugged in all these points into the calculator, we would get something that looks like this. So if we're looking at this graph, we're going to see that it's positively skewed. Remember, the tail is going to be over here, so on the right hand side, so we know it's going to be positively skewed. And if we're using our graphing calculator, we can also do something called a box and whisker plot, and it can help us identify the shape of a distribution. And one thing to know about these is that it sets it into 4 equal portions, so they're going to be 25% portions. As you can see here, it's 25%, 25%, 25%, and 25%. And this is going to be based off all the data. So, as you can see here, this is going to be, I'm going to show it. This is called a whisker. And this is our other whisker over here. And of course, these two are going to be our boxes. And if you're looking down here with the number line, you can see all the different numbers. So I know that right here, the center is just about 26, 27, which I know is going to be the center. So this is just to kind of go over what exactly each of these things are. And just like when we had the graph, the whisker plot, skewed and whisker plot, it shows if it's negatively skewed, symmetric, or positively skewed. Notice if it's negatively skewed, it's going to be more towards the right hand side. And if it's symmetric, it's going to be smack dab in the middle. Those boxes are going to be the same. And if it's positively skewed, it's going to be more towards the left hand side. They want us to go ahead and use the graphing calculator to construct a box and whisker plot for the data. So once I plotted, this is actually what I'm going to be getting. And as you can see here, it's going to be a symmetrically skewed distribution, because if I'm looking here, even my whiskers are equivalent and my boxes are also equivalent. we go.